Okay, let's see example 6. Solving the 2 times square root of 3 sine x over 2 equals 3 for all solutions. Oh, that means there is no limit for us, no bound. So easier. So find what is the solution for x over 2, and then we add 2, so equal something. I add 2 n pi. Then that is the general solution for the x over 2. Then find the solution for x. Okay, let's see this one. Isolate the sine x over 2 first. Divided by 2 square root of 3 both sides. I'm having sine x over 2 equals 3 over 2 square root of 3. Rationalize the bottom, square root of 3, square root of 3. I'm having 2, what is that? Square root of 3 over 2. Okay, so for the sine x over 2, this angle, x over 2 angle, make the sine equals positive square root of 3 over 2. I must have my angle in the first and second quadrant, and the reference angle must be pi over 3. And we must know that the reference angle all 6 over 3. So the question doesn't provide us find the angle in the radian mode or degree mode. So it's up to you. If you like to have the degree, use the degree. If you want to use the radian, use the radian. That means x over 2 maybe equals pi over 3. Or maybe x over 2 in the second quadrant is pi minus pi over 3. Is 2 pi over 3. I got 2 angles in one revolution. And how about for all solutions of x over 2? X over 2 equals pi over 3 plus 2n pi. Or x over 2 plus, equals 2 pi over 3 plus 2n pi. And here the n is integer. Then I need to isolate the x. I cannot have the 2. That means I need to use 2 times x over 2. And then I can use this color. Equals 2 times the second term, pi over 3, plus 2 times 2n pi. Okay, that means this 2 canceled. I have the x equals 2 pi over 3 plus 4n pi. And the second equation, so multiply by 2. 2 times x over 2 equals 2 times 2 pi over 3 plus 2 times 2n pi. This is x equals 4 pi over 3 plus 4n pi. So write the solution, general solution in the set notation. I'm having x for all x, such that x equals 2 pi over 3 plus 4n pi, or x equals 4 pi over 3 plus 4n pi. And for the x, all integers. All right. We're done for this one. And how about next one? Okay, so the next one. Okay, oh, this is an interesting one, but this one is a very hard one. And we need to use our calculator to find the solution. So first, let's see, solve for theta in the equation x, 11 plus 4 times sine 2 theta equals 20 theta times theta 2 theta. Oh, okay, let me say again. Solve 11 plus 4 times sine 2 theta equals 20 sine 2 theta for all solutions. That means at the end, I need to know what is the theta. There's no bound, so no given interval. So I need to find all solutions So easier question, but we need to isolate the sine 2 theta first. If I want to have my 2 theta on one side of the equation, another side is number, I can minus 4 times sine 2 theta, both sides. So we have 11 equals 16 sine 2 theta. And sine 2 theta equals all divided by 16, 11 over 16. This is not a special angle. So this one, I need to use my calculator to find the angle. Remember that for the sine, if I'm using the calculator to find this inverse of sine 11 over 16, my calculator will only give me the angle for the inverse of sine in the first quadrant or fourth quadrant. And this angle, this value is positive. So I have my angle in the first quadrant. So they only give me angle here. They will not give me the negative angle. So let's see, using the calculator to find what is the inverse of sine 11 over 16. So how about this one? Let's find the theta in the degree mode, because the previous examples, we found them in the radian mode. Let's find, I'm looking for the inverse of sine 11 over 16, 11 divided by 16, close parentheses. So that's 43.4325 something. But if I want to keep 2 decimal places, let's say 43.43. So for example, I have solved for my 2 theta. It's about, because I'm looking for the 2 theta, it's about 43.43 degrees. And this is the, my calculator gave me the angle here, 43.43 degrees. But let me ask you, but from the equation sine 2 theta equals 11 over 16, over one full cycle, sine is positive. I must have angle here. I also need to have my angle in the second quadrant here. The calculator only gave me the angle 43.43 degrees. How about another angle? So this angle and this angle, so reference angle, they are the same. That means here is also 43.43 degrees. Oh, I know how to find the angle in the second quadrant. So my 2 theta has 2 values. First one is 43.43 degrees. And another angle in the second quadrant is 180 minus 43.43. So we can use our calculator. You can say about or approximately. So this one, if I'm using the calculator, it gives me 136.57 degrees. All right. How about all the solutions? So we can find all the solution for 2 theta by adding n times 1 revolution, which is 2 pi or 360. So the 2 thetas general solution or all solution is, for the first angle is 43.43 degrees plus 360 degree n. N is integer. 2 theta equals 136.57 degrees plus 360 degrees n. I'm looking for theta. I'm not looking for the 2 theta. So divided by 2, everybody. So let's start to divide by 2. Okay, so theta equals everybody over 2. 43.43 degrees over 2 plus 360 degrees n over 2. So let's simplify the theta. So that's so divide by 2 is 21.716. So how about this? If I use 43.43 divided by 2. So it is 21.715. Okay, it's about 21.715 degrees plus 180 degrees N. And the general solution or our solution for another angle theta is 136.57 degrees over 2 plus 360 degrees N over 2. And use our calculator to do the approximation. 136.7 75 sorry 57 divided by 2, so 68.285. So if we use this number is 68.285 degrees plus 180 degree N, and write them in the set notation. I should have 21.715. Oh, sorry. No, because looking for the all solutions, that means the not only 2 points. So I have x for all the x such that x equals 21.715 degrees plus 180 degrees N. And or x equals 68.285 degrees plus 180 degree N for all the N. For all N in the so for all N are inside of the integer, so N are integers. All right, we're done for today. Oh, here I have a typo. This is not X, this is N. For all N, they are integers. And what else? Do I have any mistake? Hopefully I have no, oh, here I got another typo. So here is not X, here must be N. All right, we're done for today. If you have any question, please let me know. And have a good one. See you next video. Bye.